5, yeah.
5 inch, your slab thickness. I will say, hey, this unit width, this 1 feet, I will assume, it's up to you, I will assume I have 3 rebars. Number 3. So your area steel will be 3 bars times 0.11 area of 1 bar of number 3. Your area steel will be 0.33 inches square. Any question? I would like to be sure this steel reinforcement that I assumed is enough for this bending moment or not. This is my question. If your steel reinforcement is enough, I will say, hey, I will put in each feet 3 bars, 3 bars, 3 bars, 3 bars, 3 bars from number 3 in this direction and this direction, if only this steel reinforcement is enough. If not enough, I would like to change maybe the number or maybe the size of your bars. So how can I take this decision? This steel reinforcement is enough or not enough? Before doing this, anybody here can tell me if you have cross section with these dimensions and this cover maybe 1 inch, can you tell me what is the value of phi Mn? What is the design strength? What is the design bending moment for this cross section? Do you remember how can I get it? Yeah? We have cross section. So we have neutral axis. Above your neutral axis, we have compressive stress. 0.85 Fc prime with depth A, because your depth of your neutral axis is C. At the bottom, we have steel reinforcement, so we have tensile force T. And this compressive stress can be equivalent to equivalent force C. Do you remember all this stuff? So if you say C equal T, so 0.85 Fc prime A, B equal area steel times F yield. Okay? Keep going. 0.85 Fc prime 4,000 feet, 4,000 psi, so it's 4 ksi. A, I don't know. B, the width of your cross section, which is 12 inch, equal area steel that you assumed 0.33 time F yield 50. What is the value of A?
I got 2.47.
2.47 inch. So your nominal moment equal area steel times F yield times D minus A divided 2. Do you remember all of this stuff? So your area steel 0.33, your F yield 50, your depth 5 total minus 1 inch cover, so 4 inch, minus A divide 2. What is the value of your bending moment? How much?
I got 45.6.
45.6. Kim, inch. Can you divide this number by 12?
3.8.
3.8 kib foot. So if you have slab thickness with 5 inch and you assume each foot, each 1 feet of your slab, you put 3 bars of number 3, this steel reinforcement will support bending moment equal 3.8. We have a little mistake. Your design moment you have to multiply your nominal moment by phase. So 0.9 times 3.8, what is the final value?
3.42.
3.4. Kept foot. This steel reinforcement that you assumed in this thickness by this width for 1 feet can support a design bending moment 3.4. Do you have any question related to these calculations? I would like to be sure all of these colors equal or less than your design bending moment, because your design philosophy say, hey, your M ultimate less than or equal your design bending moment. Where is your design bending moment? Here you go. Where is your M ultimate? All of this stuff. Each value or this value called M ultimate. I would like to be sure this value or this value is less than or equal 3.4. How can I do this? Go back to your icon, slab, color fill, contour. I will start with MZ. That means you are talking about reinforcement in Z direction. Then you have something here called user defined maximum and minimum. Go ahead and put in maximum this number with a positive value, and in minimum put the same number but in negative value. So I will put 3.4 positive, 3.4 negative. Okay. What do you think? The color changed. But one more thing. I found this value becomes negative 3.4, almost. And this value almost 3.4. That's right? That means any color inside this range is okay. Any color outside this range, not okay. Please go ahead and check each color. What about this color? This color is inside. What about this color? This color is inside. What about this color? This color is inside. That means any color inside your slab in between your range, that means you are safe. Why? If you check this color, what is the value of this color? The value of this color, something between this value and this value. 2.7, 2.05, smaller than 3.4. You are safe. This value represents your M ultimate. I would like, and this value represents your Phi MN. Your Phi MN, I would like to be sure your M ultimate color in between. That means smaller than or equal. Your Phi MN. So each color inside, that means your steel reinforcement in Z direction will be each 1 feet. I will put 3 bars, number 3. What about X direction? Go back. Everything the same, just change MX. And your range, positive 3.4, negative 3.4. Go ahead and hit OK. Your colors change. We need to check this one negative 3.4, this one positive 3.4. Check each color. All of your colors in between. If yes, that means I can put each 1 feet, 3 bars, number 3. So finally your mesh of steel reinforcement, 3 number 3 in each feet, 3 number 3 in each feet. I am okay. If not, if you have a color here, for example, outside this range, what does it mean? This color, if you put 3 bars, number 3 will not be okay. What do you think? What is the solution in this situation?
Bigger rebar.
Do you think we need to increase rebars for the whole area of your slab or just for this area?
Just for the area.
Both of them correct. But the first one, if you increase your bar for the whole area, it's not an economic solution. The most economic solution, just increase your bars only for this specific area. You got it? So, design of a slab using software. We need to do some design calculations. Assume your steel reinforcement, get your design bending moment, Φmn, put your design bending moment in your range, minimum and the maximum. Your range will make this range. Each color in between is safe. If you have color outside this range, that means it's unsafe. You have two options: increase your steel reinforcement for the whole area of your slab, that's fine, or increase your steel reinforcement just for this specific unsafe area. That's enough for today. One more time. In your capstone project, you will need all of